We're going to move into our proofs portion of the class, and proofs or geometry is main focus is proofs. Okay, there are a ton of proofs in geometry. One of the things I'm going to put onto Schoology for you, and that you'll have access to, and I would definitely print this out, is a valid list of reasons for proofs. And this is just a giant list of things, of reasons, and we'll talk about what reasons are that you will use throughout the course. Okay. And I'm going to allow you to have this and use this on anything and everything. Okay. As we go through, we're going to add some things and write on here a few things. And don't write anything that I don't tell you to write. Okay. And we're going to start with algebra proofs. And the reason we start with algebra proofs is because you have done and gone through algebra. So you know about algebra, and we're going to bridge the gap to geometry with algebra. There are about 8 properties here on the front side that we're going to look at right away. And these properties fall under the Postulates and Properties category. These first 4 are very similar. Okay, addition property, subtraction property, multiplication property, and division property. And what these 4 properties, is these are doing that operation on one side. Okay, so the addition property would be adding. So adding on one side. We normally call this reducing or simplifying, but it's the addition property. When you add 2 things on the left side of an equation, that's what you're doing. So subtraction property would be the same thing. Subtracting on one side. And then multiplying on one side. This is dividing on one side. Okay, so anytime you're doing an operation on, let's say you're just combining terms on the left side, you're doing one of these 4. Now, the next 4 add of equality to each one of those. Okay, so addition property of equality, subtraction property of equality. When it adds the word of equality, that means you're doing that operation on both sides. So the addition property of equality would be like adding 2 to both sides of an equation. Okay, these up here apply to expressions, and then these down here apply to equations. So this would be add on both sides. This is subtract on both sides. This would be multiply on both sides. This is divide on both sides. Okay, and we're going to use some of these today. Okay, oh, look down here, we've got these 3 properties that we just talked about. Okay, reflexive, symmetric, transitive. Let's go ahead and put kind of a definition here. Okay, reflexive, that's the one where we're looking into the mirror. So something is itself. So we're going to say like AB equals AB. It's equal to itself. The symmetric property is we can write it either way. So let's say A equals B, then B equals A. We can reverse that order. The transitive property was the linking property. So A equals B, and B equals C, then A equals C. Okay, the distributive property and the substitution property you've used before in algebra. So let's do the substitution property first. The substitution property is plugging one thing into another of equal value. It's very similar to the transitive property, but the transitive property can link multiple substitutions. Okay, so substitution property is plugging in one thing for another of equal value. Okay, so we're just making a substitute. Like when I say x equals 5 and you plug 5 into every x that you see, that's the substitution property. Okay, and the distributive property is getting rid of parentheses. So we're going to say something like 2 parentheses x plus 5 equals 2x plus 10. That would be the distributive property there. Okay, getting rid of those parentheses. That's what we're going to stop with here, all of these, because those are the main ones that we're going to look at today. So if you open your notebooks to page 27, we're going to kind of take a look at some of these algebra proofs. Okay. And we're just going to do 4 of them here, and I don't have any markers here with me, or I would be writing some of this with markers, but we're going to look at algebra proofs. Okay, and what a proof is, proofs are made of statements and reasons and those statements and reasons support the what we're trying to prove, kind of like the hypothesis of what we've been looking at. Okay, it supports this conditional statement right there. Okay, okay, so in order to do these, you really need to know or have your valid list of reasons. Okay, and that's this list right here. Okay, so when we're doing proofs, you can have this. Okay, so I strongly suggest that you just get to know what's on there. Okay, so we're going to split our page into 4 sections here. And again, we're just starting with algebra proofs so that we can kind of get into what a proof kind of looks like. Okay, let's start. I'm going to go ahead and write 2 of these problems down. Okay. So we're going to solve these. And as we solve these, we're going to provide reasons as to why I can do each step. Okay. And when we do a proof, okay, we're going to kind of outline it in a 2-column proof. Proofs do not have to be in 2 columns. I just find that it's the most organized way of doing it. You can use paragraph form, which is kind of like English uses it a lot, where you're just writing like a persuasive essay or something. So you could write a paragraph and you can do a flow chart. But I feel that 2-column proofs are the most organized when doing this. So we're going to start here with just making our statements and reasons. Now, other than the very first reason, if you say something over here, it needs to come off of this list. Okay? It is written in black ink, copied, if you write it over here. If it is not over here, you don't write it over here. Okay? The very first one is always the same. And that very first reason is given. And your statement is what you are being given. I'm being given this, so that's what I'm going to write. I'm going to say 3x plus 2 equals 23 minus 4x. That is being given to me. That is the reason. You always write down what they provide you in the proof. Okay, so looking at this, we can do multiple things first. Okay, looking at it, I might say I'm going to add 4x to both sides. When I add the 4x over here, I get a 7x plus 2 equals 23. And if you want, you could put the little plus 4x, but you don't have to. Your reason's going to say what you just did. Now remember, I added something to both sides. I added 4x to this side, and I added 4x to that side. If we look here, when we add something to both sides of the equation, that's the addition property of equality. We're adding on both sides. So then over here, I'm just going to put addition property of equality. And we can abbreviate that. Okay, we don't need to write the entire thing out unless you really want to, but we don't have to. Okay, here my next move would be to subtract 2 from both sides. Okay, when I subtract 2 from both sides, I get 7x equals 21. Okay, now since I subtracted from both sides, that would be the subtraction property of equality. Remember, if I don't put the of equality part, we're doing it on the same side. Okay, and we will see something like that. And then the last thing, I need to divide both sides by 7. I get x equals 3. And since I divided on both sides, that is the division property of equality. And I'm done. I have what x is. That's all. Okay, so let's look at this next one. Again, we're going to set up our statements and our reasons. Our first statement will be what they provide me up here. So we're just going to say -5, parentheses 7w plus 8 equals 30. Do not change anything from what they gave you. Because if you change it, it's not what they gave you. It's not the given. Okay? All right, looking at this, there's a couple things that we could do first. Number one, we could distribute this -5 into everything there, which is what most people will want to do. So we could do that, and that's what we are going to do here. But we could also just divide both sides by -5 as well. Okay, and then you would have division property of equality. But we're going to go ahead and distribute. So we have -35W minus 40 equals 30. And I just distributed there. And if we look over here, I have distributive property right here. So we're going to write the distributive property. Okay, and then we're going to add 40 to both sides. So I have minus 35W equals 30 plus 40 is 70. And we added a number to both sides, so that's the addition property of equality. And then our last step, we're going to divide by -35. So 70 divided by -35 is -2. And since I divided both sides by the same thing, that is the division property of equality. And we're done. We have what W equals. Okay. All right, so we're going to look at 2 more. We don't have to have numbers in here. They could just be letters, and we could solve that. So let's look at these 2 problems. We're going to do let's do this problem. P R plus 1 plus N equals 2N for R. Okay, so we're going to take that thing and we're going to solve it for R. And then the last one we're going to do is going to be 2x minus 15 minus x equals 21 plus 10x. Okay, so we're going to set up our statements and reasons for each one. Proofs can be different from one person to the next. They do not have to be the same. Somebody could solve it different than the next person, and that doesn't make it wrong, as long as your reasons correspond with your statements. On the test, you may take a different route than what I have as the answer key. That doesn't make you wrong, as long as you justify properly each statement that you make. Okay, so our first statement is what they provide us, and then our reason is given. So we're going to say P R plus 1 plus N equals 2N. And you could put 4R there if you want. You don't have to, though. Okay, so if I go to solve this for R, we're trying to get R all by itself. Okay, so the first thing I'm going to do is subtract N from both sides. So I get P R plus 1 equals N. So I subtracted something from both sides. So that's my subtraction property of equality. Okay. The next thing we're going to do, okay, and we could do this differently depending on what equation you have, but I'm going to go ahead and divide. Instead of distributing P, I'm going to go ahead and divide both sides by p. If I divide by p, that goes away over here. I get r plus 1 equals n over p. And I divided both sides by the same thing, so that's division property of equality. Okay. And remember, I'm just trying to get r all by itself, so the last thing I need to do is subtract 1. So r equals n over p minus 1. And that was the subtraction property of equality. Now notice I use that property up here, and that's fine. You can use multiple properties over and over and over again. Okay, doesn't matter. You have no limit. And I'm done now because I have r all by itself. Over here, again, we're just going to rewrite what they provided us. So 2x minus 15 minus x equals 21 plus 10x. And that is given. And you should notice here that you can combine like terms here on this same side. So you have 2x minus x. So we want to combine like terms. And I'm subtracting here on the same side. Well, if we look over here, if I subtract on one side, if I subtract on one side, that's just the subtraction property. So 2x minus x is x minus 15 equals 21 plus 10x. That is the subtraction property. It's not the subtraction property of equality. It's just the subtraction property because I did it on one side. Okay, now it becomes one like our very first example. Okay, so I'm going to subtract x. So I have minus 15 equals 21. 10x minus x is 9x. And I subtracted on both sides, so that's subtraction property of equality. Okay, now I'm going to subtract 21 from both sides, and negative 15 minus 21 is minus 36 equals 9x. So again, we subtracted on both sides, so that's subtraction property of equality. Now we're going to divide both sides by 9. Negative 36 divided by 9 is negative 4 equals x. And that's the division property of equality. Now let's say I want x on the left. Okay, I can rewrite that and say x equals negative 4, but my reason, okay, the reason I can flip that around, remember here, a equals b, then b equals a. So we're going to say that's the symmetric property. That allows me to flip the order of that, okay, and then I'm done. So that is an introduction to proofs using algebra. So you'll have your big ideas assignment. Again, this list here will be on Schoology if you want to print this out. And you can fill out everything that I've filled out so far. Okay, so I encourage you to print one of these off and start filling it out with me. Okay, if you got questions, feel free to reach out.